You don't have to draw this. Just want to review again. Altitude. Tell me about it. Altitude. What is an altitude? 10?
It's a perpendicular line from all the vertices.
Okay. All right. Forms a right angle. Everyone agrees? Now I'm going to show you what's called a median now. Median. Still comes from a vertice. But the catch is, the difference, it's not perpendicular to the opposite side. It goes to the opposite side's midpoint. All right? That is called a median now. It is not perpendicular. Starts at a vertex, goes to the opposite side's midpoint. Tell me something true about triangle ABC then. If AD is a median, it goes to the opposite side's midpoint. What else can you either mark on your diagram or tell me is true right now? 2.
BD is equal to DC.
There we go. BD congruent to DC because medians go to midpoints. Medians go to midpoints, correct. All right, so there's one median in this triangle. Grab your compass because we're going to construct another median right now. And if you look at the directions right below triangle ABC, it says, hey, do it from point C, please. So I need to draw a line from C to the what of AB? What C to where?
Midpoint.
The midpoint. Ooh, how am I going to do that? I need, using that compass and straight edge, how do I find the midpoint of AB? Because it's nothing new I'm going to show you. We got a construction out there that goes through a midpoint. What have we been doing here all along here? You can do the same construction as the Actually, I should probably even do that. I don't want to give it away. What's this construction? I need to find the midpoint of AB. And there's one construction we know of that will find that midpoint for us.
Perpendicular bisector.
Do a perpendicular bisector. Good, John. So we're going to take our compass, put it on B, and do what? Or A.
Open it wider than half.
Open it up more than half the length. Yep. We're going to make a decent size arc. And then we're going to go over to A and make that same decent size arc. So they intersect in how many spots? 2 points of intersection, not one. Shoot. But don't do anything after that. Please, please, please do not draw anything in after you have the 2 arcs. And this is why I asked not to do it. Is that my median? Is that a median? No, why not? Because it doesn't come from where? It doesn't come from C. That's not a median. But it is what? And I need you guys to understand the difference between a median and what this line actually is. What is it? What did I just draw in? Thank you. A perpendicular bisector for side AB. That is not a median. But will it help us find the midpoint still? Yeah, because look at, see where my line crossed AB? That's the what? That's what I need. So you might want to just line up your straight edge, mark where the midpoint is. Don't draw on the line because that's not my median. That's a perpendicular bisector. Then can you draw on the median now? Okay, line it up. Line up point C with your midpoint and draw it in. There's a median using constructions. But again, everyone see that's a median. You draw the line through your construction. That's a perpendicular bisector. All right. Questions? Now, would it be wrong if I drew it in as well? That's fine. This is still a median. That's a perpendicular bisector. See the difference between the two. All right. Let's play a little game now. A little game called What is Segment CD up here? What is Segment CD? You have 4 choices. Here are your 4 choices. They should sound familiar. Your 4 choices for CD are: is it a perpendicular bisector? Is it an angle bisector? Is it an altitude? Or now, is it a median? Those are your 4 choices for CD. Which one of the 4 is it? Because these are the only 4 type of lines we've talked about. So take a look at diagram A. Be ready to answer. Diagram A. CD is a, give me your best name for that bad boy. 6. Median? Medians go to where, Nick? What did we just go over? Medians go to a midpoint. Do you know that AD and DB are congruent? No, I do not. So it can't be a median, but I do see that it's coming from a vertex and is what to the opposite side here? So that makes it N? Altitude. Good. Everyone all right? Altitude? Perpendicular to the opposite side. Altitude. All right, how about diagram B? CD is going to be, best name for CD here. It's 28. That is a median because AD and DB are equal, meaning D is the midpoint. All right, we're moving right along. How about diagram C? CD, best name for that one? It's 27. Angle bisector. Because both of these are 28 and 28. Good. And here comes a little bit tougher one. Please make sure you're looking at CD right there, please. What is CD in that diagram? $17. Oh, thank you. 10. That darn right it is. It's coming from a vertex, and it's perpendicular, forms a right angle down below. Good. All right. Questions? All right. Let's turn our focus back to medians then, because this is our last pair of lines here we need to talk about. Give you a second. Go ahead. Plot triangle ABC, and we'll go. Okay. Find the midpoint of each side so we can draw in each median. So we're going to draw in all 3 medians right now. As a class, can we just find the midpoint of BC very quickly now? Without having to use the midpoint formula, can everyone locate the midpoint of line segment BC? And can you draw in that median for me with a straight edge? With a straight edge, please draw in that median. You don't need your compass. Just find them. Just put a point where the middle is. That's it. Algebraically now, here's what's going to happen. Algebraically, these 3 groups in the back, you're going to find the midpoint of AC for me. These, what do we got? 4 groups in the front. You guys are going to find the midpoint of AB for me right now. Again, let's do this. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Let's go. You guys in front got AC. You guys in the back have the midpoint of AB. Just find the midpoint of your side. That's all I'm looking for. All right, midpoint AC. Anybody from any of the groups? Midpoint of AC? AC, what do we got? 5. 5, everyone graph it for me. 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And draw in the median coming from B with a straight edge. And anybody have the midpoint of AB?
5, 3.
5, 3. Everybody graph it for me. And draw in the median using a straight edge. This is day 4. Day 4. Use some vocabulary when I ask you this question, please. What do you notice about the medians in a triangle? Medians in a triangle. What can you tell me about the medians in a triangle using some vocabulary term? 22, the medians. What do you notice about the medians in this diagram?
They're concurrent.
They are concurrent. Everyone agree? So that means I can go back to my chart from earlier today in class. Medians now are concurrent. Medians. Where are they concurrent? Here's our new vocabulary term. It's already on there for you. It's not like a big reveal. The medians are concurrent at a point called the centroid. Centroid, right? Centroid. That's where the medians intersect, the centroid. So finally, something that doesn't have the word center in it. Centroid. So what's the special fact? Huh? Well, I'll give you a fact that you can impress people with later today, but I don't care if you remember it or not about the centroid. If I give everybody a pair of scissors right now, and I asked you to cut out that triangle that you graphed, and if you got a very, very sharp pencil point, and you took your triangle, put your pencil point right where the centroid was, let go, it would balance. It would balance right on your pencil. The centroid is the center of gravity for any triangle. It's the center of gravity. So if you ever try that out, that's find the centroid, put your pencil point right underneath, and it should, no wind in the air, balance perfectly. The actual fact I need you to remember, not that one. I guess you can impress people later. The actual fact is a little bit more mathematical, and that is it splits a median into a ratio of 2 to 1. Splits any median into a ratio of 2 to 1. Stay on your graph here. Stay on the graph. What is the centroid on this graph? Can anybody give me the coordinates of the centroid here? What are the coordinates of the centroid? For this triangle ABC that we just worked on the graph, what are the coordinates of the centroid? 14?
4, 4.
Make sure you count from the origin.
6, 4.
6, 4, I believe, right? Yep, 6, 4. All right, so what do I mean about this 2 to 1? Watch. Here's what I mean about 2 to 1. Let's say this is 16, has a length of 16, this segment right here. The other side, 8. 2 to 1. One more, couple more for you. 20 here. Other side, 10. The question that usually comes up is, where's the bigger piece? How can I always know where the bigger one is? The bigger piece on the median is always from the centroid to the vertice. Everyone see where I put the 20? Centroid to vertice is always the bigger piece in the 2 to 1. One more because I'm not confident yet. Let me put a 2 there. What's this piece going to be? Yes, bigger piece, centroid to vertice. Yes, we are right on the 2 to 1 now before we apply it. All right, let's apply it. WM is 16. M is the centroid. What's WX? Notice what I'm looking for. I'm looking for WX, which is the median now, the median. Before I do WX, how about MX? I need that before I do that whole thing. How long's MX? Based on this new 2 to 1 fact. 22?
8.
8. So WX, 16 and 8, 24. All right. Another one. YM is 12. How about YO and MO? Let's start with MO. How long's MO? 26?
Oh, sorry. 24.
24? So now it looks like YO is not that bad, right? 36? Whew. What are we doing for this next one here? Whoa. Anybody see the word centroid in the directions? I don't. So how are you going to know on the next quiz this is going to be a centroid problem? Why isn't it a circumcenter problem? Why isn't it an in-center problem? What in the directions tells me this is going to be centroid? What in the directions up here says, oh, you might want to start thinking centroid and not circumcenter, in-center, orthocenter? 16? What's up here that says this might be a centroid problem?
Because all 3 of A, D, B, E, and C, F are
Medians. And if they intersect at G, G is a centroid. That's what tips me off that this is a centroid problem, that it's medians intersecting. Not altitudes, not angle bisectors, they're medians, so that means I have a centroid, which means I have 2 to 1. BG, 2x plus 10, GE, 3x minus 1. Let me put something down that is 100% false, and somebody out there is going to correct me. False. Right? Absolutely false. It's not a ratio of 1 to 1. It's a ratio of 2 to 1. Adjust it for me. There's a couple different ways you can adjust this so it is true. Make it true. 5, make it true.
2 times 2x plus 10 equals 3x minus 1.
So we're saying BG. If you're saying, let's see, if that's 16 and that's 8, I want to double that part, Claire?
Oh, no. Yeah.
Right? I don't want to double that part. Which part do I want to double?
3x minus 1.
Correct. If you wanted to do something to the 2x plus 10, I could do what instead?
Divided by 2.
What's that?
Divided by 2.
Or multiply it by a half. Yes. All right, but I can't multiply 2x plus 10 by 2. I'm making that bad boy even bigger now. All right, go ahead. I'm not looking for x, but I am looking for BE, so I'll give you guys a second or two to find x and plug it back in. 9. When you're ready, let me know what BE is.
BE 104.
104? Is that what you said?
Yeah.
What'd you get for X?
19.
Okay, where did that come from? Did we start with the same equation?
Oh no, I copied that backwards. My bad.
Well, we just said we can't double the 2 part.
Yeah, I
Right.
accidentally doubled the 2 part.
23? What do we get for BE? For BE? What'd you get for X?
X equals 3.
Yep. So then you plugged it in, and BG was 16, right?
Oh, yeah. And then, okay. And then, 24.
GE was 8, so you should have BE was 24. Yep. I'm starting number 1 on the homework with you, so any issues on here? All right, I'm starting number 1 on the homework so you know what the expectation is for the rest of the chart. We'll do the perpendicular bisector row together so you understand what the rest of the chart should look like. Also, this is your study guide right here. This is your study guide for the upcoming quiz. All right, everything all in one chart. All right, perpendicular bisector. What is it? What's it do? Description. What is a perpendicular, in your own words, what does a perpendicular bisector do? 22?
It's equidistant.
No. That you're starting to think about points of concurrency. Just a perpendicular bisector. What's it do?
It cuts perpendicular line in half.
Cuts a perpendicular line in half. Can't cut a line in half.
I'm at angle, like 90 degree angle.
Okay, let's regroup here. Let's start with the example first. Let's start with an example first, and then I'm coming back to you. If I have a triangle and I ask you to draw in, because there's 3 of them, just draw in one perpendicular bisector. Draw in one perpendicular bisector. Now describe to me what you just drew in. Describe to me what you just drew in. What did you draw? A line segment, array? What did you draw?
I drew a line.
Okay, tell me something about that line. A line that does what?
It's perpendicular to the opposite side.
A line perpendicular to a side. Is that it? Just perpendicular?
And it bisects a side.
What's bisects? Because you're kind of just telling me that. All right, so a line perpendicular to a side and cuts it in half. And then you guys could have drawn anything that looks like that. Does it have to come from a vertice? Look, you got 4 terms up here. This is the only one that doesn't come from a vertice. Or doesn't have to, I should say. It could, but doesn't have to. The other 3 have to come from a vertice. There's a good perpendicular bisector. Only one that does not have to come from a vertice. All right, I draw all 3 in. What's the point of concurrency called? 1. Circumcenter. And special property about it. 7. Equidistant from, instead of angles, we say vertices. That's what I'm expecting from the other 3 rows as well. All right, so go ahead, finish that up, and try to get through some of those centroid questions before you leave.